In this video, we're going to look at ions. Atoms of various elements can gain or lose electrons to form ions. And it's the electrons that are gained or lost because they exist on the outskirts of my atom. Those are the most easily lost or gained as opposed to my protons and neutrons, which are housed in that central core. So ions will come in two flavors. We can have cations, which are positively charged, and these have lost electrons, meaning that there are more protons now than electrons. We also have anions, which are negatively charged, and these have gained electrons. Now there are more electrons than protons. Let's look at an example. Take calcium 2+ cation. And let's say we're looking at a specific isotope, maybe calcium 40. So we know this mass number, 40, is the sum of the protons plus neutrons. And we can determine the number of protons from the periodic table. It's the atomic number Z, right? So we have 20 protons. And the neutrons must also be 20, such that it adds to 40. And then electrons, we have to think about this because we've lost electrons due to this positive charge. In a neutral atom, the protons will equal the electrons. So in a neutral calcium atom, we would have 20 electrons. But we have 2 more protons than electrons, as noted by the 2+ charge, so we must have just 18 electrons here. Now I'd like you to give it a try by determining the number of protons, neutrons, and electrons in the bromine ion, and specifically bromine 79. The number of protons in bromine is 35, and so the number of neutrons must add to the number of protons to give 79. So this would be 44. And the number of electrons in a neutral atom is going to be 35, but we have a negative charge, meaning that we have 1 more electron than protons, so we'd have 36 electrons in this bromine anion. So far, we've looked at atomic ions, that is, ions that are individual atoms. Ions can also be polyatomic, however. So something like the sulfate ion, SO4 2-, is an example of a polyatomic ion. If we add up the protons and electrons across all of the atoms in the ion, we would find that there are 2 more electrons than protons. An example of a polyatomic cation would be the ammonium cation. Here, if we add up the protons and electrons, we would have 1 more proton than electrons. There's one thing that you need to know about ions, and that's that you will never find them as an individual ion. They always come in pairs. Just like Batman and Robin and pancakes with syrup, you'll never have an anion without a cation. So if you went to the chemical store and asked to buy a bottle of chloride ions, they'd probably give you a strange look. You'd end up having to buy those chloride ions as an ionic compound or a salt. So sodium chloride, magnesium chloride, potassium chloride could all serve as sources of chloride ions. And an ionic compound is something that consists of a cation and an anion. These cation and anions will come together to form an organized lattice structure as shown here. And this organized lattice structure, once it reaches a large enough size, will start to form crystals. And these crystals are what we recognize as maybe table salt or rock salt that you use in the winter. Those are crystalline structures that consist of anions and cations arranged in this neatly ordered structure. Now we know about ions as charged atoms that have gained or lost electrons, and when they come together they form these ionic compounds or salts. So please let me know if you have any questions, and thank you for watching.